Means substitution means if we are just adding something. For example, this is done in the unsaturated hydrocarbons. Sorry, unsaturated hydrocarbons. For example, if there is an element has utilized its full combining capacity. Okay, a hydrocarbon has utilized its full combining capacity. There are all single bonds here. But if we want to add the chlorine to it, so if you want to add the chlorine to it, then one hydrogen should be replaced from it. Okay, and another is going to be added. Okay, so when there is a substance is being removed and another atoms or a group of atoms are being added, this type of reaction is known as substitution reactions. What we called it? Substitution reactions. And this reaction take place in the presence of UV rays or sunlight. Okay, and important thing is that we are not going to disturb the structure, the original structure of this one. Okay, so we are not going to disturb the original structure. So this is sunlight. It occurs in sunlight, and first of all, it occurs in UV rays or sunlight. Okay. Second thing is that it occurs in saturated hydrocarbons, saturated hydrocarbons. And the third point is that one atom or group of atom or group
Good
of
evening, sir.
good evening everyone, or group of atoms are being replaced by another reagent. Okay, reagents. So this is the substitution reactions. So note it down here. Substitution reactions, the reaction in which a reagents or substitutes replace an atom or a group of atom from the carbon chain without disturbing the structure of the original hydrocarbon. These are generally shown by saturated hydrocarbons and benzene. Done this one? Done?
Yes,
No,
sir.
sir. No, sir.
Okay. Next is, if I talk about this one, that for example, if we are having methane when added to chlorine, so one of the hydrogen atoms will replace and one chlorine atom will make bond with this one and it will form chloromethane. Okay, this will form methane and hydrochloric acid. And when we keep on adding, if we are just continuously passing the chlorine gas, then another hydrogen atom will be replaced. The two chlorine atoms will be added and we keep on adding. At the finally, we will have all the chlorine atoms. Okay, we'll have all the chlorine atoms and there will be no hydrogen atoms bonded with this one. Okay, so please draw these reactions. Draw these reactions. Drawn? When you're done, please let me know, okay? Done? Noted everybody?
Done,
Tell me
sir.
first.
Yes.
Okay. Now, properties of ethanol. There is going to study the properties of ethanol and how ethanol is formed. Okay, we shall be going to discuss this one. Do we have discussed the oxidation? Oxidation combustion reaction, do we have discussed?
No, sir.
Do
No,
we
sir.
have, do we have discussed that why that saturated hydrocarbons burns in open air when they burns in open air, they burns with blue flames. When unsaturated hydrocarbon burns in open air, they burns with
No,
blue.
sir.
We have
No,
not.
sir.
Okay, let's discuss first the combustion reactions. Okay, where we have some question, important one. Okay, combustion, chemical properties. Note down the topic, chemical properties of hydrocarbons. Chemical properties of hydrocarbons. Okay, the first property of hydrocarbon is that whenever we are just burning any carbon, whether it is diamond, whether it is anything, any form of carbon, like it is diamond, graphite, okay, Buckminster Fuller, anything. If we are just burning the carbon in the presence of oxygen, it will gives you carbon dioxide plus heat and light. Okay. And you know that hydrocarbon is going to have hydrogen also with carbon. So if we burn hydrocarbon in the presence of oxygen, then it will gives you carbon dioxide and water. Carbon, when carbon burns in this hydrocarbon, it gives you carbon dioxide. And when hydrogen burns in this one, it will gives you water. Okay. But there is important point you need to note it down that oxygen should be needed in sufficient supply. Okay. When sufficient supply, if it is given in from open air, means sufficient supply can be given from open air and from external supply also. So note it down, please. Combustion reactions. Done? Done?
Yes, sir.
Everyone?
Yes, sir.
Okay. Now moving to the next part. If we are just burning any hydrocarbons in if saturated hydrocarbons are burned in open air, okay, like if I'm having saturated hydrocarbons, okay. Saturated means in which the carbon is utilized at full combining capacity, means all carbon atoms are bonded with single bond. So if I'm having saturated hydrocarbons, and if you are burning in open air, okay, then they burns with blue flame. They will give you carbon dioxide plus water, okay, and they burns with blue flame. But if unsaturated hydrocarbons, okay, hydrocarbon, hydrocarbons, if they are burning in open air, okay, if they burn in open air, then they burn with sooty flame. They will give you carbon dioxide plus hydrogen plus water, but there are some unburned carbon particles also. Unburned carbon particles would be also present there. Okay, you understood? Unburned carbon particles. This unburned carbon particles is there. Why? Because the open air does not have much oxygen as comparison to which is being required to burn the unsaturated hydrocarbon completely. For example, if we have CH2 double bond, CH2 or CH triple bond, this one. Okay. So some of the carbon, when we burn it in open air, okay, there must be always some unburned carbon particle plus carbon dioxide plus water. And this unburned carbon particle present in the flame change the color of the flame. Actually, when we are having a candle, which is an unsaturated hydrocarbon, wax is an unsaturated hydrocarbon. When we burn the wax candle, okay, this burn with sooty flame. Sooty flame. Okay, why? Because the color of the flame is sooty flame means red yellow flame. Red yellow flame I'm talking about. Okay, and this is red yellow. Why? Because of the presence of unburned carbon particles. Okay, actually it is blue in color, but due to the presence of unburned carbon particle which are not burning, the blue color of the flame changes to red yellow. Okay, everything burns with blue flame. Okay, every saturated hydrocarbon burns with blue flame, and unsaturated hydrocarbons also burn with blue flame. But due to the presence of unburned carbon particle in the flame, they change the color. The unburned carbon particle change the color of the flame from blue to red yellow flame or sooty flame. Okay. You understood? That's why the
Yes,
proof
sir.
of this one is that that when you burn a candle and you place a spoon over it, you will find that your spoon will get blackened. Okay. So why it is get blackened? And what is that black colored substance that is depositing on the lower face of the spoon? That is the unburned carbon particle present in the flames. Okay. So since saturated hydrocarbon burns in open air, they will give carbon dioxide plus water like alkane. But if alkene or alkynes burns in open air, they will give you carbon particles plus CO2 plus water. Okay, note it down.
Done, sir.
Done, everyone? So here,
Yes,
sometimes
sir.
question is being asked that noted down the saturated hydrocarbons burn with blue flame in open air, while the unsaturated hydrocarbons burns with sooty flame in open air. And this is a test of saturated and unsaturated hydrocarbons. Okay. So if you burn the saturated hydrocarbon, it will burn with blue flame in open air. If you burn the unsaturated hydrocarbon, it will burn with sooty or red yellow flame in open air. Sooty flame means red yellow flame is produced due to the presence of unburned carbon particle in the flame. Okay. Okay.
Yes, sir.
Note it down. Saturated hydrocarbons even burn with sooty flame if insufficient supply of oxygen is given in open air. Okay. Saturated hydrocarbons even burn with sooty flame if insufficient supply of oxygen is given in open air. Yes, you. Mm. The students, how your studies is going on, everybody? Charisma, Abdullah, Adil, and other students.
Sir, I was studying chemistry only before the class.
You were studying chemistry only. Why? Why only chemistry?
No, no, no. I was studying chemistry before the class.
Okay. And you, Samina, how your studies is going on?
Good, sir.
Because soon I'm going to start taking your test. Hiba,
Yes, it's going good.
how your studies is going on?
They are going good.
They're going good. Okay. So please do this one fast. Noted?
Then, sir, yes, sir.
Just tell me that how can
So
you,
1 minute.
is there any examples of your daily life that you can see that saturated hydrocarbons can burn with sooty flame?
Sir, our kitchen stove, like it has a blue flame.
Yeah, it burns with blue flame, but sometimes it start blackening the
Yes,
utensils.
sometimes, sometimes.
Sometimes. Why it start doing this way? This way? Because there may be
Because
some.
there are some unsaturated hydrocarbons.
No, because there is not unsaturated hydrocarbons. Actually, there is a power, there is a supply. Okay. Like I'm just having this burner. Okay. There is no inlet holes are there. Okay. And there are inlet holes. Okay. So if this is an LPG is coming here, let me grab this one. Okay. So these are the air inlet holes. Okay. I'm talking about this one. So these are the air inlet holes and these are the burner that through which uh, the gas is LPG's gas is coming to this way and it is moving like this way. Okay, it is coming out. And if we are having air inlet holes, these air inlet holes, when the air is moving sorry, gas is moving very fast speed through this holes, through this nozzle, through this pipe. So the surrounding air, which is carrying oxygen, get mixed with this one. Okay, and it combines with the gas and help in burning. But if there is no air inlet holes present, or if the air inlet holes are chalked, or if we are having something which is not going to have air inlets, so then this will start burning with sooty flame because this time uh the oxygen is not completely mixed, which is going to mix with air inlet holes. Okay, so this is the reason why it will start burning with sooty flame. Same thing happens if the air inlet holes are present, but if they get chalked for somehow reason, if they get chalked, then the inlet holes, the oxygen that is entering through these inlet holes get chalked or get blocked. It is not mixing. So in the insufficient supply of oxygen, saturated hydrocarbon can burn with sooty flame. Okay, understood?
Yes, sir.
So please note it down. Question is why utensil get blackened sometimes in gas stove, knowing that LPG is a saturated hydrocarbon.
Then, sir.
Done? Okay. So this is the question. The answer for this one is that this is one reason, first of all. The one reason is that there may air net holes may be chocked. Okay, so that's why that is blocking the uh, atmospheric oxygen to get mixed with the gas. Okay, burning gas, so that it can burn completely with sufficient supply of oxygen. Okay, and the other reason may be that due to less pressure in the cylinder, sometimes the pressure is less, and if the pressure is less, then the speed of the gas that is moving through this pipe becomes slow, and as a result of which this air surrounding air did not get mixed with this one. Okay, so this may be the second reason. So if the if the cylinder or if the pressure is less in the cylinder, then this problem may occur. Okay, so here the answer for this question. Saturated hydrocarbons LPG can also burn with sooty flame if the flame burns in insufficient supply of oxygen. Okay, means if the gas burns is in insufficient supply of oxygen, utensil get blackened due to the presence of unburned carbon particle present in the flame. Okay, why there are unburned carbon particles? What is the reason of unburned carbon particles? The reason behind this is simple, that these unburned carbon particles actually are the carbon particle that are making the utensils blacken. Okay, so these are the reason. And what are the reason? What is the reason? That it may possible to the following reason. First of all, that air inlet holes may be choked. Okay, first reason is air inlet holes may be choked. A second reason is less pressure in the cylinder, due to which sufficient supply of oxygen is not entering through the inlet holes. So note it down, please. Noted?
Yes, sir. Yes, sir.
Why are you not answering? So what are the reasons? Tell me what are the two reasons. Fast. Tell me what are the two reasons why the utensils get blackened. Tell
So
me.
because of the inlet
Maybe
holes,
maybe
and
chop.
then yeah,
The second
and
reason.
then the less pressure in cylinder.
And what is the what if there is less pressure in the cylinder, then what is happening?
The insufficient supply of gas, you can say.
Insufficient supply of oxygen will means we can say that less amount of oxygen will enter through the inlet holes. Okay. So generally it is it you can
Yes.
observe this one, that most of the time when we have the new cylinder, then it burns with blue flame. But when the cylinder is going to get, means if there is no gas supply in the cylinder, or we can just it is about to finish, then we then start blackening the utensils. Okay, so this is the reason, cause of less pressure. Okay, next one is one more question comes through the is from this topic is acetylene gas. Acetylene gas is a gas which is ethine, and welders use. Okay, ethine is a common name for acetylene gas. Ethine. Ethine means eth means two carbon. Why ethine means, okay, this is ethine. So actually, when we burns ethine is an unsaturated hydrocarbon. So when we burn it completely, then it will gives you carbon dioxide, water plus large amount of heat and light. Okay, and this gas ethine, this ethine gas or acetylene, we call it acetylene gas. Okay, acetylene gas. So this acetylene gas is used for welding purpose. Is used for welding purpose. Okay, but since it is an unsaturated hydrocarbon, it is an unsaturated hydrocarbon. hydrocarbon. Okay. Then there is an external supply of oxygen is being needed. Okay, are you getting my point? External supply of oxygen is being needed. Why? Because in order to completely burn it, okay. Because if no external supply of oxygen is given, if it is burned in open air, it will burn with sooty flame, and it will produce unburned carbon particles. And if there is an incomplete combustion is taking place, means carbon is not burning, there are unburned carbon particle present, so it is not burning, so it will not produce the amount of heat that is being required for welding purpose. Actually, in welding, we need large amount of heat so that metal can be melted, and uh, the purpose of welding is done. Okay, because we need to melt the metals. So that for that one we required a very means a fuel which is going to have high calorific value, which can melt the metals. Okay, and it can be only done when we are just burning it completely. Okay, are you getting my point?
Yes, sir. Yes, sir.
So this is an acetylene gas. So let me show you that how do welders use. So we in the acetylene gas. Okay, just a minute. We having a rain in India. Just give me a second. Mm. So I'm going to show you. You may also have acetylene. So you can see here that, okay. So this is burning. This is used for melting purpose. So you can see here that these are that it is having the two pipes. Okay, it is having two pipe. One pipe is here, one pipe is another. So one pipe is carrying oxygen, external oxygens. Another pipe is going to have the acetylene gas. Okay, the two pipes are having different gases. They mix together and they are burning. Okay, you understood? Everybody understood this one?
Yes.
So this is the purpose of actually. That they were having the two cylinders, and if you burn it, if we are not having any external supply of this one, then actually it will. Okay, so this is, so please note it down that why do welders use an extra supply of oxygens while while using acetylene gas during welding? The reason behind this is, one, acetylene is an unsaturated hydrocarbons which burns with sooty flame in open air, i.e. burn incompletely. Sooty flame means it burns incompletely. Okay. So due to this, high temperature requirement for melting metal is not fulfilled. Means if something is burning incompletely, then how can it gives you the sufficient supply of temperature that is being required to melt the metals? So if you acetylene is gas is burned in open air, so it will burn with sooty flame, which is going to have unburned carbon particles. Incomplete combustion is taking place, so no temperature, high temperature will it able to provide. So when extra supply of oxygen is given, then it burn completely and burns with blue flame, which provide high temperature, which is sufficient to melt the metals for welding purpose. So note it down. Okay, noted. I will be coming back in a minute. Okay. Done? Noted? Tell me fast. Have you noted this one? Yes, students?
Yes, sir.
Okay, so this is an important question that is being asked in the examination. Why do acetylene burns? Why there is an extra supply of oxygen is being required? Okay, so you need to know, note it down, and you need to know the common name of this one. That acetylene is the common name for ethine gas, which is an alkyne. Okay, do everyone have noted? Should I move forward?
Yes, sir.
Okay, next is the oxidation reactions. Do we have studied the oxidation reaction?
No, sir.
No, sir.
No. So let's study the oxidation reaction. Now, what is the difference between the oxidation and combustion? In the combustion, the hydrocarbons burn with flame actually. Okay. And we can say that the most of them are going to give you the same result, that is uh, carbon dioxide and water. Okay. Carbon dioxide and water will be the end product of the combustion generally in most of the hydrocarbon cases. But in oxidation, the addition of oxygen or removal of hydrogen is taking place and new substance is being formed, and there is no combustion, like flame is not taking. Okay, so what is oxidation? This means that the chemical reaction which involves addition of oxygen and removal of hydrogen. So if we are adding something, okay, so let me explain you here that, for example, if I'm having ethanol, C2H5OH, ethanol, okay, and if I add it with alkaline KMnO4, alkaline KMnO4, or acidified potassium dichromate, or acidified acidified potassium dichromate, K2Cr2O7. Okay, then these both are strong oxidizing agent. Okay, they will provide the nascent oxygen. Nascent oxygen means that is not in the molecular form. So I'm writing it like this way: 2O, that will provide you. I can write it O2, but O2 is the molecular oxygen. So if just I write atomic oxygen, 2O, then it will gives you CH3COOH, ethanoic acid, plus water, So here you can see that ethanol, which is a alcohol, which is an alcohol of two carbon, alcohol, alcohol of two carbon, it is burning to gives you ethanoic acid, okay, of two carbon. So carboxylic acid means alcohol actually when it is added with alkaline KMnO4, alkaline KMnO4, okay, then it will get converted into carboxylic acid. Carboxylic acid. Write it properly. Alcohol when react with alkaline KMnO4, then it will gives you ethanoic. Sorry, not ethanoic acid, because it is alcohol, so it can be carboxylic acid. Carboxylic acid. Okay, plus water. So here the question comes in examination that what is the role of this one? What are they doing? Are they acting as a catalyst? No, they are acting as an oxidizing agent. They are acting as an oxidizing agent. Okay, because they are being used here. They are being utilized here. Okay, and this is the Purple color. Purple color of this one get disappear to colorless. Okay. Done. So please note it down that oxidation of ethanol is very important. It is being asked in the examination. So how many types of question is being asked? The first type of question is being asked for the that it is acting as a strong oxidizing agent, whether it is acting as a catalyst. So no, it is not acting as a catalyst, because catalyst means that it is a substance that is being used to increase the rate of the reaction. So if we are adding purple color solution that is of alkaline caminophore is going to have purple color. So even if it is being used, or if it is being used in the mid of the reaction, its color may be disappear. But when the reaction get finished, the amount of alkaline caminophore we have used, it must be in the same amount and with the same color. But here the color is being disappeared. So it means that it is being utilized. Okay. Got it? Got it?
Yes, sir.
So you noted down that C2H5OH, which is ethanol, when it react with this one, alkaline caminophore or acidified potassium dichromate, the color of alkaline caminophore is purple color, it get disappear. And if we have this one, acidified potassium dichromate, okay, then light green color of this one will disappear. Means potassium dichromate has light green color. So this get disappear. So okay, note it down, please. And why it is considered to be as oxidation reaction? Because removal of hydrogen is taking place. You see here there's a 6 hydrogens, 5 and 1 6, but here it is 4. There is only one oxygen here. There is 2 oxygen. So addition of oxygen and removal of hydrogen is taking place here. Okay, note it down, please. Done this one?
Yes, sir. Done.
Okay. Next is, if we are having unsaturated hydrocarbon, there is a test of unsaturated hydrocarbons also, that if we add purple color substance to it, okay, that alkaline caminophore is known as Bayer's reagent. This is very commonly being asked and important. You need to memorize this one, okay? So when we add water plus, when we have unsaturated hydrocarbons and we add water plus alkaline caminophore to it, which is called Bayer's reagent, which is called Bayer's reagent. Okay. So plus O, then it will gives you CH2 single bond CH2. We have OH here and we have OH here. Okay. Done. This is a test for this one. Okay, the alkaline KMNO4 color will disappear. Okay, color of alkaline KMNO4 will disappear. Okay, so if you add Bayer's reagent or alkaline KMNO4 to unsaturated hydrocarbon, its color will disappear. If you add it to saturated hydrocarbons like CH3 single bond CH3 plus water, okay, plus alkaline KMNO4, no color will change. No color will change. Okay, no color will change. So this is the test for saturated and unsaturated hydrocarbon. If it is being written in the question that other than combustion, you have to tell the test for the saturated and unsaturated hydrocarbon. So this is the test. Okay, got it? Note it down, please. Test for saturated and unsaturated hydrocarbons. Done?
Yes, sir.
Okay. So if we have ethanol, alkaline KMNO4, then it can be used to convert ethanoic acid. Okay. So the question comes that how will you convert propanol to propanoic acid? If the question comes, how will you convert? How will you convert propanol to propanoic acid? Propanol to propanoic acid. How will you convert propanol to propanoic acid? बताइए. How will you convert propanol to propanoic acid? What is propanol? 3 carbon alcohol. Okay, C3H7OH. This is prop and all. And if you add it to alkaline KMNO4, KMNO4, then it will get converted into propanoic acid, which is C2H5COOH. This is propanoic acid. 3 carbon. 2 here, 1 here. Propanoic acid. Acid plus water. Understood, everyone? Why you're not responding?
Yes, sir.
Yes,
Okay.
sir.
So note it down, please. Done?
Yes, sir.
Now let's move toward the chemical properties of alcohols. Note the topic, chemical properties of alcohols. Of alcohol. The first property of alcohol is that alcohol when react with metals, alcohol when react with metals, they will give you salt plus hydrogen gas. And this same property is of acid also. Acids when react with metals, it will give you salt plus hydrogen gas. So why do alcohols are not characterized as acids? Okay. First of all, let me write for example, if I'm having C2H5OH, ethanol when react with sodium, it will give you CH3C. When ethanol react with sodium, it will gives you C2H5ONA. C2H5, C2H5O, and then Na. Okay. So this is sodium ethoxide, sodium etho oxide, and plus hydrogen gas. Okay. Like if we have propanoic acid, C3S7OH, then it will give, when it react with metals, it will gives you C3S7ONA, sodium propanoate, propanoic acid, ethane oxide. Side. Okay. So plus hydrogen gas. If I ask you a simple question here that this sodium ethoxide, and if the question comes in examination that both alcohol and acids when react with metal, they produce hydrogen gas, and this property is same to alcohol, are resembling the same property as that of acid. Why do alcohol are not characterized as acid? Why do alcohols are not placed in the category of acids? Still, they are producing hydrogen gas like the other acids too. The simple reason is that because acids, when react with metal, they produce hydrogen gas. But when you add acid to water, they dissociate H plus ion. They dissociate H plus ions, which alcohol do not dissociate. Alcohol do not dissociate H plus ions in aqueous. H plus ions in aqueous. Okay, so this is, you need to memorize this one. So please, here we have a question. Note it down. Ethanol, write this reaction. Ethanols on reaction with metals. Yeah, alcohol. Reaction with metals will give you salt plus hydrogen gas. Okay, then write this question. Okay, this is the first property of alcohol. Okay, are you writing this one?
Yes.
Note it, please.
Done, sir.
So question comes, ethanols on reaction with metal produce hydrogen gas. This property is similar to acid. Then why it is not characterized as acids? The reason, in the NCERT it is being written that since ethanols in water does not dissociate the H plus ions like the other acid do, that's why they are not characterized as acids. Put it down, please. Done this one? Noted.
No, sir, doing.
Doing. Noted.
Done.
Okay. So here we have some questions. Just give me a minute. On your screen. What would be the answer if you have this one? Question number 6. What should be the answer for question number 6? Tell me.
Sir, C.
What should be the answer for question number 6?
Sir, C. Catalyst.
No, it is not acting as a catalyst. I have told you that it is not acting as a catalyst.
Sorry. B. Oxidizing agent.
Yes, it acts as an oxidizing agent.
Yes.
Color of the purple color disappeared, and this indicate that it is not being. Moreover, it is providing the oxygen. It is participating in the oxygen. Okay. Ethanol when react with sodium, it form two products. These are
Sir, sodium
Sir,
ethoxide and
C.
hydroxide. Hydrogen.
Hydrogen.
Sir,
Yes,
C.
sir, C.
C.
is the correct one.
Sir, I told first.
Okay. Okay, we have done this one. How is ethene? Ethene can be prepared. Ethene we have not from ethanol. We have not done this one. Okay. A gas is evolved when ethanol react with sodium. Name the gas evolved. This is the same type of reaction being asked 2 times. Question number 38, same. Okay. Unsaturated hydrocarbon contain multiple bonds. Okay. Between the two carbon atoms. Show this is an addition reaction and show addition reaction. Give a test to distinguish between ethane and ethene. How can you distinguish ethane and ethene? Question number 43. Tell me first. How will you distinguish between ethane and ethene?
So, is it with the use of alkaline KMNO4?
Yeah, if you burn it in open air, first of all, yeah, that is
Yeah,
also.
yeah.
Then one will
Yes,
burn,
sir.
ethane will burn with blue flame, while the ethene will burn with sooty flame. The other test is when you add it to alkaline KMNO4, then unsaturated hydrocarbon will change the color. Okay,
Okay,
got
sure.
it? Okay. Which of the following in ABCD is a substitution reaction? Substitution reaction. Which of the following in ABCD is a substitution reaction?
Option C.
So, option C, yeah.
C. Yes, it is C is correct. Here it is being written that what is the role of the metals or the reagent written on the arrows in the given reaction. So we have just studied this one. So what is the role of this one in C written on the arrow? It is acting as an strong
Oxidizing agent.
Oxidization agent.
oxidizing agent. Okay. Here is a question. Look at the other students also can don't think that your class is not being started. Okay, we are just studying your words also. So I'm just talking about Jaslin, Jobita, and Abir. You have recently joined. So let's discuss important questions from this portion, and we shall be discussing the acid, bases, and salts today. So here, if we have ethanol, this reaction is given to you. This is ethanoic acid, and there is sodium carbonate here. Okay, sodium carbonate. So sodium carbonate when react with alcohol, sorry, acid, it will gives you carbon dioxide plus water. But if you have ethanol here, then no carbon dioxide will be produced. Okay. So we will discuss this one when we will just going to. Here's the question that how will you convert propanol to propanoic acid? B part. How will you convert propanol to propanoic acid?
Through oxidation reaction.
Yes. By adding it to alkaline caminophore, this will be converted. And how would you bring about the following conversion? Name the process and write the reaction involved. Ethanol to ethylene that we have not discussed with the students. Okay. So ethanol to ethylene can be converted by adding it to concentrated H2SO4. Okay. So that's all, dear students. You can leave.